I wanted to work through in determining enantiomers one more time in a similar way to what we saw in lecture on Thursday. We're looking at chiral carbons. Right, it's a chiral carbon. You need to have four unique substituents. And an enantiomer, right, are non-superimposable mirror images. So all I'm going to do is going to reflect this chiral carbon with four different substituents. I'm going to reflect that through a mirror. And so right now I've got two unique substituents. I'm going to add in my third unique substituent, where each color obviously indicates a different substituent. And so here would be enantiomers, non-superimposable mirror images of each other. And if I took this structure and just copied that structure and brought it over here, we would see that with a little bit of just rotating this structure, right, a little bit of counterclockwise, we would see that green would align with green. So I'm just going to take green, and instead of spinning it around, I'm just going to replace, move it slightly. I'm placing green over here. Now we can see they are non-superimposable mirror images. Blue aligns with blue, green matches with green, but purple and red, they are opposite of each other. So no matter what we do, we will always be able to align two of the three different colors. We'll always have two out of phase with each other because they are non-superimposable mirror images. And that might be hard to see and think about spatially. And so just another way of thinking about it or looking at it would be to just imagine this is your eye and you're looking down from blue. You're on top of blue looking down. And the same here. You're up here looking down. What would you see? So if you were looking down that carbon-carbon bond, the blue bond that's indicated there, right, we were looking down on that, we would see blue, and then we would see red, we would see green, and just start putting in the enantiomer over here. For the enantiomer, I would look down and I would see blue, and I would see green off to this side, and I would see red here, and I would see the purple. So maybe it's a little bit easier to see when you're looking down that carbon-carbon bond that, okay, here are non-superimposable mirror images of each other. I just flipped those through a mirror. They're non-superimposable mirror images, and yet when I take this structure and bring it over here, I can spin it around, right? And now we can see that looking at those two structures, the blue and the purple align, but red and green are opposite of each other. Non-superimposable mirror images. No matter what I try, I'll be able to align two of those, and I'll have two of those colors out of phase. That's an example of chirality. That's an example of enantiomers, non-superimposable mirror images. It might have been a little bit harder to see up here, looking at the tetrahedral example, but it's the same thing down here, only that we're looking at a top-down approach. And so it's easier to see that those colors match up. Two of those four colors match up. So hopefully that helps think about and kind of understand the orientation, the spatial orientation that's taking place between two enantiomers.